We've looked at how to evaluate limits using graphs and also algebraically by hand. Now what we want to move on to is looking at how we can use Wolfram Alpha to evaluate limits and then apply limits to solve some application problems. Before we get into that though, we want to introduce a new type of function called an average value function. So if we recall that c of x represents our cost function and tells us the total cost for producing and selling x units, we can talk a little bit about what we mean specifically by evaluating that function at different points. So if we evaluated our cost function at 1, that would give us the cost to produce one item. If we evaluated c of 2, what that would tell us is the cost of the first item plus the cost of the second item, which is a little bit different than saying that c of 2 gives us the cost of just producing the second unit. So it's not the cost of just the second unit. So whenever we evaluate c of 2, we're always evaluating a cumulative cost, the cost for producing that second item plus all of the previous values. If we wanted to generate the cost of just the second item alone, we would need to take c of 2 minus c of 1, or the cost of whatever item we're interested in minus the cost of all of the preceding production. So following that same pattern, c of 3 would be the cost of the first item plus the cost of the second item plus the cost of the third item. So again, it would be that cumulative cost. So evaluating c of n for some arbitrary value n would be that cumulative cost of the first item plus the second item plus the third item plus on and on and on, all the way up to whatever that nth item is that we're considering. So by total cost, we always mean the cost to produce exactly how many items we're substituting in for x into that cost equation. So building off that idea, we could establish the average cost per item by finding the cost of item 1 plus the cost of item 2 plus the cost of item 3, and on and on and on, all the way up to the cost of that nth item. Or actually, in this case, let's call that the xth item. So if we found out the cost of producing each of those items individually, added all of those up, and then divided by the number of values that we produced, that's just the same thing as finding the average of a set of numbers. What this would be c of x, so the cost of producing that xth item and all of the preceding items, divided by x. So actually, let me keep that notation consistent here. So c of x over x is the cost of producing the first x items. And if we consider all of those individually and divide by the number of items we're considering, that's, again, just that formula for finding the mean of a data set, or the average of a set of numbers. So c of x over x we can refer to as the average cost function, which we would represent as c bar of x. So what this means is we can construct an average value function for any given function by taking that original function and dividing by x. So c bar of x, the average cost function, would be c of x over x. Similarly, r bar of x, so our average revenue function, would be r of x over x. And we could also do the same thing with our profit function. P bar would be p of x over x. And in each case, what we're doing is finding the average cost per item at a production level of X units. So in our first two examples here, we want to find the average cost function for C of X given this cost function. So in order to find that average cost function, we take our given cost function divided by X, which we can then leave as stated, or what we could do is break that up into the sum of different fractions. So we could break this up so we would have 4,300 over X, 16X over X, but 16X over X would reduce to just 16, and 25X squared would reduce to just 25X. So in this case, just two different ways of representing the same solution. Similarly, in example 2, we want to find the average profit function, P bar, for P of X. So this would be our original profit function. Divided by X. Then what we want to do is evaluate and interpret P bar of 25. So that result we just found is P bar of X, the average profit function. So now what we can do is take 25 and substitute it into that equation and evaluate to generate a result of 5.5. And now focus on what we mean by interpreting that result. So now that we've generated P bar of 25, what does that information tell us? In this case, it means that at a production level of 25 units, the average cost per item is $5.50. So that's not the exact cost for producing any particular item, but out of the first 25 items, on average, we're spending $5.50 to produce each of those first 25 items.